All right, we're going to skip over to example 8, which is on page 31 to do next. And it's got the height, h, in feet above the ground of a golf ball depends on the time, t, in seconds it's been in the air. So it goes up and comes down. Claire hits a shot off the tee that is a height modeled by the velocity function f of t is equal to negative 16t squared plus 80t. So in this f of t is going to represent the height, which is h. So we can calculate the height by filling in to that formula. All right, so A, we're going to factor the function to find our zeros. So I'm going to take negative 16t squared plus 80t. I'm going to factor it. It's negative, so I'm going to factor out a negative 16. Goes in both 16 and 80, and I can take out a t. And that's going to leave me with t, and then that's going to make this be minus 5. We want to know what the zeros are, so we want to know where this is equal to 0. So that's going to be where negative 16 is equal to 0, or where t minus 5 is equal to 0. So use our zero factor property. Here we're going to divide both sides by negative 16. That leaves me with t is equal to 0. And here I'm going to add 5 to both sides and get that t is equal to 5. So these would be our zeros. So this represents the spot where h is equal to 0. Now on our graph, h is equal to 0. If we come down to our graph, t's are dependent variable and then our independent variable, and then h is going to be our independent up here. So where h is equal to 0 is down here, so it's going to represent the spot on the x-axis. So these are going to be numbers on the x. I'll just put x-axis there. All right, so B, I want to create a table of values and sketch the graph that represents the function. Well, if you think about it, we've just said that our graph is on the x-axis at these 2 points, 0 and 5. So we want the numbers in between 0 and 5. So I don't think I have enough spots here. I'm going to put 0, 1, 2, 3, 4, and 5 here. Now what I'm going to do is I'm going to use my calculator to calculate the heights by plugging each of these numbers into my formula here. So 0 is going to give me a 0, and we already know that 5 is going to give us an h of 0. So now I need to plug these in, and I'll show you how to do this next class. So next class, you need to make sure to bring your calculator because we're going to have many more problems where we're going to be using it. So make sure that it's charged. All right, so at 1 second, it's 64 feet in the air. 2 seconds, 96. 3 seconds, it's 96. 4 seconds, it's 64 feet high. And at 5 seconds, it's 0, so it's on the ground again. How long is the ball in the air? So it starts, goes up, and comes down. So it's in the air for 5 seconds, from 0 to 5. Those represent our seconds. So what is the, oh, we need to graph it, don't we? So let's talk about that. Let's graph it. That may help you see those pictures a little better. So we're going to come down there and we're going to plot those points. And again, I'm going to stop and then plot, and then you can check back. You plot yours too. All right, so here's my points plotted, and you can see we're not going to go straight across because we know it's a parabola. So when we draw it, we know that the middle is going to be in the middle somewhere there, right there. So we're going to go up and just kind of estimate what it's going to look like here up there in the middle. So not a pretty parabola, but there it is. So you can see here that here's my time from 0 to 5 seconds that we put here. The maximum height of the ball, I'm going to come down here and I'm really going to do this. So you can see the maximum height is going to be right here. We're not real sure. We kind of drew the picture so we have a good guess, but we don't know that exactly yet. So what is the height of the ball no, how long after it's hit does the ball reach the maximum height? Well, here, this is at 2 seconds, and this is at 3 seconds. So we know that we have symmetry and that the vertex is right in the middle of 2 and 3. So the middle of 2 and 3 is going to be 2.5. So here I'm going to put the middle of 2 and 3, and it's going to be exactly in the middle, so 2.5. So to figure out what the maximum height is, then I'm going to let t be equal to 2.5, and I'm then going to plug it into my formula again using my calculator to come up with my answer. And my answer, when I do that, when I figure out what f of 2.5 is, that's going to be equal to, when I plug it in, I get 100. So it's kind of what I ended up getting, pretty close right there anyway. So what is the height of the ball at 3.5 seconds? So again, we're going to use our calculator, and we're going to plug 3.5 in to figure out the answer, and the answer is going to come out to be 84 feet. So I don't know if that looks like that's going to work or not. Yeah, we're pretty close right there. Is there another time at which the ball, so here it is right here. There's my 84 feet. So is there another time at which the ball is the same height? Well, if you think about it, we just talked about the symmetry. This is in the middle here at 2.5. So there's my vertex. And then it was at 100. So there's symmetry. So if I have 84 on this side, I'm also going to have 84 on this side. So if that was over from the vertex 1 this way, it's going to be 1 the other way. So it's going to be, so yes, in 1.5 seconds, it would be the same height. So then my next question is, how long is the ball 64 feet or higher in the air? So I'm going to come back here, and you can kind of see that happened. The 64 happened at 1 second and at 4 seconds. So all the way from 1 second here, it's in above that until I get over here at 4 seconds. So that is going to represent 3 seconds. Oops. That's going to represent 3 seconds that it was in the air. And then what's the domain and range? Well, remember the domain is going to be the x values. So here, so t is going to go from 0, it stops at 0, hits the ground there, to 5. So I'm going to say that 0 is less than or equal to t is less than or equal to 5. And then the range then is vertical. So again, it's at 0 is the low point and 100 was the high point. So I'm going to say 0 is less than or equal to h is less than or equal to 100. All right, so charge those calculators, and I'll see you next class.